The resource person of the day, Professor A. Ravi Kumar, sir, IEEE delegates and dear participants, a very good evening to one and all gathered here.
What I say.
I welcome you all for the 29th webinar. That is the webinar series organized by IEEE Malabar Subsection in collaboration with Malabar Hub. And today, this is our 29th webinar. It is handled by Professor A. Ravi Kumar, sir. And the resource person will be speaking. Today, he will be handling a session on novel antenna test facilities and Anechoic chambers. Let me introduce the speakers to the audience. Dr. Professor A. Ravi Kumar, sir, he is the former scientist of Space Application Center, ISRO Ahmedabad. And he is the immediate past chairman, IETE Hyderabad Center. His academic qualification includes he is having a BTech degree in the Electronics and Communication Engineering in the year of 1983, and he had a BTech degree in the year of 2004, and recently he has completed a MBA degree in marketing. He has started his career as a scientist or a scientist engineer at ISRO Ahmedabad in the year of 1983. And he has worked for the development of a space-borne radar for Earth observation. He held senior positions in space research, industry, engineering, and education administration. His work experience included in the area of ISRO Ahmedabad, Palatex in International Limited, VR Sri Siddhartha Engineering as a senior lecturer. He is Electronics System Private Limited, Hyderabad. He acted as a technical manager, and he is also acted as associate professor at Mahatma Gandhi Institute of Technology, Hyderabad. And he acted as professor and head of Electronics and Communication Engineering Department at TRR College of Engineering. He is also a professor in Electronics and Communication Engineering at CMR Engineering College. And he is also the director of AP Antenna Products. He was also the director of AP Antenna Products, Hyderabad. And still he is continuing as director at AP Antenna Products, Hyderabad. He holds that is, he is already having a 36 years of experience in research and development, teaching under UG and PG, and also he is having a very good industry experiences. He's having a strong multitasking capabilities, ability to prioritize tasks and have good follow-up skills. Exceptional drafting and communication skills, problem solving, organizational and project management skills also he had. And he is a strong professionalism with the ability to consistently demonstrate tact and maturity, facilitate professional relationships, and support efficient execution of all of his administrative requirements. And he is also a strong teaming and collaboration skill that foster office unity and cohesiveness in support the office administrative requirements. He is capable of handling a large workload, effectively coordinate multiple resources, and multitask in a fast-paced environment that may often have competing priorities with minimal assistance. So we had today, the 29th webinar, which is organized by IEEE Malabar Subsection in collaboration with Malabar Hub. Today we have graced with the presence of Professor A. Ravi Kumar, sir, to handle the session. So I welcome you, sir, for the session. Off to Ravi Kumar, sir. Ravi Kumar, sir, are you there? Your audio is not connected now. I request you to please connect your audio. Sabik sir?
Yes.
Sir, Ravi Kumar sir audio is not connected now.
Okay, wait 1 minute.
Hello, I am online again.
Yes, sir.
Yes, sir.
Sabik, yeah, I
Yes, sir.
sent the mail to you, Sabik.
Wait.
Did you receive once? Sit and do it.
Sir, I am already given an introduction.
Okay, I understood. And Sabik, did he receive the PPT sent by me?
Yes, sir. 1 minute, downloading.
Yeah, fine. So I think I would like to extend.
Now you, yes, sir. Now
Yeah,
you can only
I
start,
start
sir.
up with my presentation. First of all, I have to regret and ask for excuses for all the invitees who are waiting for this occasion today, and because of my laziness and not sharp at certain things, I fail to maintain the punctuality. Kindly excuse me, sir. And I would like to say this. This is a wonderful opportunity given to me to have you as my guests of this webinar. And I found from Sabik that the topics so far dealt in these webinars are really very interesting, prominent, and very useful to the present day situation where we are going through this 2020 pandemic. And I'm afraid whether this particular topic I have chosen would give you any inputs to appreciate my presentation. But still, I am taking a daring step to present this. This particular topic is about antenna measurements. As you all must have seen the title of the topic today. This is an age-old topic and is no more relevant. It is understood as, or it is misunderstood as no more relevant to the present day requirement. All the students in the engineering colleges are now rushing towards latest technologies like artificial intelligence, machine learning, deep learning, other things. My presentation open.
Sir, 1 minute, sir.
Yeah. Sorry. ఇక్కడ నాకు ఆయన ప్రజెంట్ చేస్తారు. ఓకే. Right. I'll do it. Sorry, yes, sir. Fine. Go ahead. Sorry. Hello. Okay. Yes, Mr. Sabik, is it?
Wait, sir.
Yeah, just I'll wait for a minute, and meanwhile, we'll do that. This particular topic is about novel antenna test facilities, anechoic chambers. As I have begun my introduction, nowadays the antennas are least respected. Computers are most respected. I'm sorry to comment like this, but we all know as electronics and telecommunication engineers or computer science engineers, we all originated from a basic engineering, that is electrical engineering. Back in 40, 50 years, there were no words like electronics or computers. We all have come out from a single core branch, that is electrical. And now the technology have made our lives very comfortable and similarly very complicated. Sabikji?
1 minute, sir. It's getting some downloading problem. Wait.
Yeah, so I'll go with my introduction meanwhile. So I must give you some introduction about the antenna before Sabikji is going to share the video of all the products, all the topics what I have come out with. Any test antenna that is designed need to be tested for its performance. We all know that there are number of antennas which are used for different purposes: broadcast, communication, mobile communication, satellite communication. And so many other things, like some antennas are placed on board a satellite in different bands: L band, C band, X band, S band, KU, K, all that. Anyway, that I am not going into the frequency bands. These antennas, which are to be used for their purpose for which it is designed, before they are put into use, they must be tested. Anything that is designed need to be tested, validated, and approved for its purpose. So that is, it has to comply to the specifications what it is designed for. So these antennas of different types need to be tested, and the only method to test an antenna is to have a facility. We cannot test the antennas wherever we want. We cannot put it in our car garage and test it. We cannot put it in our engineering college lab or any facility where we have equipment. The prime requirement of antenna test measurement is the place. The place should be in such a way that there should not be any other electromagnetic energy other than what it is designed for. Let us say an antenna is designed for some frequency, L band, S band, X band. That too in a particular frequency spot, let us say 8.5 gigahertz. Yeah, I now.
Sir, now it's shared.
Yeah, that's nice. This is great. Sabikji, sorry for the trouble.
Okay, no problem, sir.
Fine. So now we start with the second slide. This shows one image of a chamber which is called anechoic chamber, where antennas are tested. These chambers are especially designed to test the antennas. What are these chambers and what is there inside it? If you see the next slide, please. Sorry. Yeah, you see this is a big chamber. We can see. What I want to tell you is this particular chamber is pasted with some absorbing material. All blue cone side or cone type or pyramidal type absorbers are meant for absorbing electromagnetic energy. Why it should be absorbing electromagnetic energy, I will discuss about. A gentleman standing inside the chamber actually is not supposed to be there inside the chamber while the test is performed, the testing is conducted. He has come inside to fix the antenna. If you see just opposite to, sorry, on the left hand side of the picture, there is one wall. In between on the bottom part of it, there is one another stick kind of thing where there is another antenna placed on it. He is holding one antenna, fixing it, another antenna, there is one. So there are two antennas. I would like to just ask you to notice it. Another thing to notice in this particular chamber is all the 6 sides, interiors of the chamber are pasted with electromagnetic absorbing material. Whatever electromagnetic impinging on that, radiating on particular these absorbers will be absorbed. Why that should be of that shape and size, we will see later. Next slide, please. All the 6 sides of the chamber are pasted with absorbing material. Next slide. In the next slide, Sabik.
Next slide, sir.
Sorry?
It's next slide.
You already set it, right? Okay. In my, all right, I got it. So this is another typical diagram or the picture of one test facility where there is a pedestal on which on the first left-hand side of the left-hand side photograph, you can see there is a blue pedestal on which a conical horn is mounted there. That is yellow in shape, in color, and there is some kind of arrangement, this particular mechanical arrangement. You can move the antenna in both X direction and Y direction. And on the right hand side pic, same thing is shown here. Next slide, please. Next slide. It is.
I think it's delayed. I think.
Okay. You're right. So In the next slide, you will see some kind of white spherical items held in the hand by me, and they are on display. These spherical items are nothing but standard spherical observers to validate the antennas. It has got standard radar cross section. What is the purpose of this? I will tell you later. This is a standard corner reflectors and spherical observers, which is used for calibrating. Next slide, please. Right. In the next slide, I must say that antenna measurements are basically tested, and antenna have got some specific features, specifications, that is the radiation pattern, VSWR, bandwidth of the antenna, polarization, and antenna gain, efficiency, back to front ratio, and its temperature withstanding capabilities, and attenuation kind of thing. Next slide, please. See, in the next slide, there is one antenna, test antenna, put in pink color, where it is kept on a positioner, and on the right hand side there is one another source antenna. On the previous pictures, when you observed, the gentleman holding one test antenna, and on the left hand side corner there is another antenna under test. The only two antennas are placed in the anechoic chamber. No other source of energy is kept inside. The next slide, please. The next slide says the opened view of the anechoic chamber, where you have on the left hand side there is one standard gain antenna. On the other side, there is one on the pedestal, a test antenna under test is kept there, and these are the observing material placed on all sides of the walls. So the purpose of this anechoic chamber is to have no electromagnetic energy in that particular area. This is the criteria for any antenna to be tested. Let us say there is one antenna designed for 8 gigahertz, and that is kept in open environment, and it is put on use. And we are also trying to test the particular antenna and transmitting 8 gigahertz signal from the test antenna, standard antenna, to the antenna under test. What happens? Other than the source radiation, there will be a lot of 8 gigahertz signals in the universe that are being received by the receiver. If the particular receiving antenna is receiving signals from n number of sources, there is no method, there is no clarity whether that particular antenna is performing or responding to the transmitting antenna or so many n number of antennas in the universe. So, as I have mentioned, this chamber's name is anechoic chamber. Anechoic means when there is a radiating signal from the standard antenna, there will not be any reflected rays from the walls. So all the rays falling on the other walls, let us say on the ceiling, left hand side wall, right hand side wall, back wall, they all get attenuated, absorbed, scattered, or made to get absorbed totally, and only the direct ray from transmitting antenna will reach the receiving antenna. So I want you to please appreciate the concept, the single concept here. The transmitting antenna will be focusing towards the antenna under test. It is something like a torchlight where we get a focused light towards a target. we will not be able to see the other surrounding areas because it's a focused torchlight. This is the concept in anechoic chambers, and the name also have come from that concept, anechoic. We all know about echoes, sound echoes, reflections of sound from obstacles. This anechoic is opposite of echoic, so it's anechoic chamber. Next slide, please. So I have mentioned that we need a place to test it. Place means it cannot be a garage, as I mentioned, because we have a lot of walls there, side walls, top walls, which we get a lot of reflections from the other sides, and the total power received from the transmitter is not known. And space is ideal to test the antennas. But still, I have a doubt. Space is a place where it is understood that there is no radiation, but it is wrong. Even in space, there is radiation. But for the sake of telling why space is taken, because there won't be any heavy signals in space. Testing the antenna, whatever antenna we develop here, design here, to put it in space and test it is practically impossible. Next slide, please. So there must be some alternative for this concept. So the concept is to, as I have mentioned in the beginning, there should not be any reflected rays from the surroundings. Earlier in 1950s, when the Second World War is over, there was a great requirement for antennas to be used for different purposes, mainly for radar purposes. So these antennas were tested in open test ranges. There used to be large marshlands like Run of Kutch in Gujarat, where there is no tree or no building, no wall or no pole or anything. There will be only a reflection from the ground, which is considered as an acceptable obstacle, and the ranges or open space ranges are used. But we cannot run off Kutch every time. So there is another range, something like reflection range. Even that have got some obstacles and discontinuities. So anechoic chambers are the best methods we can go for. And these anechoic chambers are designed by the concept of absorbing material, microwave absorbing material. We all crave to have some concept, some material to attract the microwave energy and receive it, like what we used to do it in our childhood. These Ceylon radios, we used to listen to Ceylon radio, and antennas are not receiving it properly. So we want always antennas, but we don't want absorbers. But as it is required to arrest the electromagnetic energy in testing a antenna that is designed newly, we have to have a anechoic chamber that is possible only because of by the invention of microwave absorbing material called RAMs, RAM. Of course, as I have told, this particular text will say something like zigzag fashioned, triangle shaped microwave absorbers, pyramidal shapes. So they are all very different in nature, and as per the requirement they are designed. So next slide, please. So this is a typical picture of anechoic chamber, just to show that the antenna, sometimes if you see the, please notice the pedestal, that plastic kind of thing, where the antenna is mounted and rotated 360 degrees. The antenna which is under test need to be tested for its side lobes, main lobe, back lobe. So for every meticulously it is planned, that is called a positioner, which rotates the antenna under test with the instructions from the computer that is placed outside the chamber. Next slide, please. So antenna, of course, what I wanted to say is the antennas testing is, of course, is another demanding requirement. And there is a criteria for antennas, how they can be tested. That is, a far field condition is to be met. Any antenna radiates electromagnetic energy in spherical wave fronts. It is something like a bubble getting burst into waves. So this wave motion will be traveling to some distance, and beyond that it becomes a planar wave. A planar wave only can be tested. The spherical wave, it has got very varying features and it cannot be taken as standard receiving energy from it. So the far field conditions we call it. And there is another concept. The distance between these two antennas is another criteria. That is the Fraunhofer lines and minimum distance criteria, 2d square by lambda. This particular formula is the one that defines the far field conditions. The size of the antenna and frequency of operation. If we substitute in this formula 2d square by lambda, that gives the minimum distance r. What should be the minimum distance between these two antennas? So the antenna is operating at very low frequency, L band, S band. We need to have a minimum distance between these two antennas, something like 100 meters. If it is megahertz, means it should be more than 200 meters. If a low frequency antenna is to be tested, I think we have to go for a anechoic chamber of the size of a basketball court or sometimes a football court. Please, so there is a criteria how to minimize the size of the antenna by taking the other concepts into consideration. And there is one other thing I forgot to mention in the previous slides. That was about the radar cross-section area of a target. Generally in warfare, the targets are only bombers and aircrafts. Of course, unfortunately, aircrafts are also bombed in few occasions in Iran and in Syria, I think previously. Kanishka or something was targeted. So the radar cross-section area defines the visibility of the object. If the radar cross-section area is big, the radar can trace it. If it is smaller, the radar cannot catch it. So please, next slide. I have given a simple example of radiation pattern. Typical example on the left-hand side, there is a bomber where it reflects the energy like that. In all 360 degrees, if you plot it on the graph, the received signal is like that. Of course, that has no much relevance, need not bother about now. But I would like you to identify the two sentences below this. What are Rafale top features are? We all know that Rafale bombers are very ultra modern and it has got capabilities and infinite capabilities. I am not here. I'm not going to deal with those capabilities of its war. Now I would like to talk in terms of radar cross-section area. The bombers are made to have less radar cross-section area. It is something like a bee, a honey bee. If there is a bomber F-22 bomber, the radar cross-section is made so small by the design aspects that radar can identify that as only a honey bee. And if you see the second paragraph, it says it's a mosquito. Rafale bomber can never be identified because of its speed, maneuverability, and other aspects. Other than that, technically, it is unidentified by the radars anywhere. So I have given a simple example of a mosquito, the size of a mosquito. So here I have given one photograph where a big aircraft is kept in the anechoic chamber to test its radar cross-section area and other compatibilities. So this anechoic chamber, I have not practically visited it, but I am amazed to see it. I have been working with this anechoic chamber design, fabrication, installation, testing, commissioning, and consultancy with Bharat Electronics Limited from almost 25 years. We started with observing material design for ECIL for their LOS links. And then we improvised our thought process and technology on the requirement and request by encouragement from BL scientists. We could develop micro observing material. But this particular anechoic chamber, which I am seeing, it is a wonder for me how this is being built and managed, and it is very expensive. Next slide, please. So just I have given one open test range. I wanted you to realize that the source antenna in green is transmitting a signal to the test antenna on the right hand side, and the green signal is direct signal. It is wanted, whereas the red signal, which is a reflection from the ground, is unwanted. Next slide, please. So as I said, there are so many constraints, and only anechoic chamber is the option to test the antennas. As I said, it is in the desired direction, we want the signal to be received, and undesired directions, we don't want any energy traveling towards the antenna under test. And surroundings should not affect, as I have put it in red. So anechoic chamber is free of echo. Last 3 lines, please go through that. Other radiated signals are not present in the anechoic chamber because this is a zero electromagnetic environment. I just would like to give an analogy to the zero G, zero gravity area, where in International Space Station and on moon and in space, where there is no gravity. Here in this anechoic chamber, we will not have any radiation at all. Next slide. That shows about, I have already discussed about how a spherical wave front is traveling to a distance to become a plane wave front. So this is 2D square by lambda criteria. We cannot keep the receiving antenna before this distance. This is a criteria. And the near field measurements is another concept where the antennas can be kept together very nearer to it, but there is a parabolic dish antenna needs to be used as a reflector to make the spherical wave front into planar wave front. Next slide, please. And this is the criteria about minimum distance between two things like antenna under test and antenna standard antenna. Next slide, please. And I would like to run down through the salient features of this system. I don't want you to be bombarded with all technical details. This particular slide says that the frequency, lower the frequency. Please go to the last but one sentence. At some micro frequencies, the minimum distance could be 5 meters, whereas in other ranges, other frequency range, it should be 20 times the size of the antenna. The third bullet says that. Next slide, please. And this is already I have discussed, but the frequency connected to wavelength, connected to the diameter of the antenna, all these things influence the size of the anechoic chamber. Size of the anechoic chamber is very important. It is very expensive job to install, facility to install. We have so far installed 5 anechoic chambers in Bharat Electronics Limited and radar cross RCI and other companies like ICOM, ACD Communications, and some places in Sirma Communications in Chennai. And we're also working with antenna designers in private mode as well as defense. Next slide, please. And this is a concept like quiet zone. I have mentioned that at the receiving antenna place where it is located in the chamber, though there is assurance from the chamber designer that there will not be any reflected rays, still we have to prove that there is at least 2-meter cube sized quiet zone available where the test antenna is placed. Antenna under test, AUT. The first sentence says the quiet zone must be large enough to encompass the AUT. So this is another technical thing. We need not bother much about it. Next slide, please. This shows a typical indoor range with one of the reflected paths, direct paths between AUT and source antenna. The flower-like things are radiation patterns of the antennas. The first left-hand side antenna, the transmitting antenna, is being kept focused on the side wall, and the reflected ray is still coming to the received antenna under test. This is okay. It's only a small example to explain it. Next slide, please. And observers, the key design item in the microwave anechoic chamber is RF observer. There's nothing else in this. If we have the RF observers that work at that particular frequency, that is the end of the design. But of course, it is not so easy as said. The anechoic chamber has corners, floor. It should be equipped with walk-on observers and roof. And generally, the micro observer is designed for a wide band of its operation. Something like 1 to 18 gigahertz used to be the beginning of micro observers and chamber design. Now the frequency operation has changed and increased. Now it is designed for up to 40 gigahertz, 1 to 40 gigahertz. Of course, it is not so easy to go with the design. So it is always advisable to have a specific absorbing material or the anechoic chamber for KU band and above and KU band and below. It is not, though it is a tasty proposal to have a single chamber that works for an entire band from 1 to 40 gigahertz, but it is practically not feasible or practically not realizable. Next slide, please. This is about rectangular far field chambers. See, this rectangular far field, I want you to please appreciate the concept here. We are having a rectangle shaped chambers. It's not square in shape. The distance between the anechoic chamber, in the anechoic chamber, the test antenna and the antenna under test should be far enough. So we cannot have or afford to have a wider chamber. We should have a longer anechoic chamber. For that particular instant, I would like to mention to you, there's one chamber which is 110 feet long in RCI Hyderabad, installed by Emerson and Cumming, Belgium. Emerson and Cumming are pioneers in radar observing material design, fabrication, and implementation. They have got very wide range of products, and I must say they are fathers in this particular field of micro observing material. And I was inspired by Emerson and Cumming designs and lectures almost 30 years back, along with my senior professors from IIT Kharagpur, where I picked up this concept and started working on this almost from 1985 onwards. Next slide, please. This particular slide shows a sheet of absorber held by me, and these are used on board a warship in Mazgaon Dock Limited, Bombay. See, warships, if you see on the decks of these warships, of course, we cannot realize where this particular radar antenna is placed. There are some anglers where they are placed and covered with some plastic covers, protect from it, from environment. So these observers, it's a small deviation from anechoic chamber. This is a micro observer in not in pyramidal shape. It is in sheet, something like 12 by 12 inches. And these observers have got different base. This particular, we used to do it in coir, where Kerala is very popular. We used to get coir foam, coir in the slab size of 2 by 2 feet with a higher density. Generally, they are used for foot mats and other vehicles and other things. But we used to go to a company industry and ask them to get us the coir foam, coir slabs, 2 by 2 size with higher density. So we had experience, and these particular coir observers are used by ECIL for their line of sight links in dish antennas. Back in 80s, there was a big demand and expansion of Doordarshan networks all over India. So all the DD links are through LOS links. Of course, BSNL are another using that particular frequency. And this other thing is, I told you about the, I think, FDPU, high density polyurethane foam, and this neoprene based, and coir, of course, we discussed. Next slide, please. So this anechoic chamber design, is, of course, we have already discussed about it. Size of the antenna, frequency of operation, such are the things to be kept in mind. And next slide, please. This is another shielded chambers. This is also small chambers, micro absorbing. For testing the antennas, mobile antennas, in Chennai, there's one company in Sirma called Sirma, that is in Tambram, SEZ. We have given a container sized. So container means it is something like 15 feet long and 10 feet wide, less than that, and height also something like 8 feet. So these are enclosures. And need of microanechoic chamber, of course, we all know that it is meant for testing the antenna, nothing else. We have to create one environment free of electromagnetic energy, and this free electromagnetic energy is possible only in the anechoic chambers. Next slide. And I have just given you two pics where the bomber F-22 is kept in the chamber and tested for its radar cross-section area. And other one, of course, a typical micro anechoic chamber where the standard horn is fitted on the transmit side of the test facility. Next slide, please. Sabik ji, do I have some more time?
Yeah, you can take
Another 5 minutes?
yeah.
Right, sir. So these are the micro absorbing material. If you see the left-hand side, there is one, the standard size of the observers, pyramidal observers are 2 by 2 feet, and it has got pyramidal observers. And on the left-hand side, they are called wedges. On the left-hand bottom side, they are called slabs or flat observers. And if you see on the fourth diagram, the energy falling directly under the tip of the observer, it travels entire length of the observer and gets attenuated. And other slant angles, they are less attenuated, but with the diffraction effect, this adjacent observing material will absorb that also. Next slide, please. This is another anechoic chamber where some plate is tested. And this is how the antennas, micro observers, before we put it in the anechoic chamber, the observer is also to be tested for its frequency. So this one method, ARC method, standard method by IEEE. IEEE is the standard for every electronics and telecommunication computers nowadays. Not nowadays, from the beginning. We have great regard to IEEE, and I'm fortunate that I'm able to be one among you today. And this is operating frequencies, and I don't think I have much to deal with this system, this topic anymore. So I request Sabik ji to come to the last slide, that is conclusion. And there's nothing to specifically mention in the conclusion part, because we all understood by now that the requirement of anechoic chamber, who are the users of this, and why students are not interested in microwave engineering, because they're one of the toughest subjects in engineering. And one has to understand what is wave propagation and how it is attenuated by and scattered by interaction with the environment, material, surface transmission. These are all dry subjects. Anyway, I'd like to thank the IEEE Cozy Code Center for giving me this opportunity to be with you for this 1 hour. And once again, I request you to excuse for the delay in setting my system on. Thank you very much, sir. Yes, Sabik.
Thank you, sir. Thank you, sir. Giving a wonderful session, even though it was started a little bit delayed. But the content that you have taken out is very useful for the beginners. What actually is anechoic chamber? Because people won't see, they will learn only antenna and wave propagation, the subject.
Okay.
After they forget everything. But how to test and how to design an antenna and how to test that designed antenna, that all depends on this chamber, how effective is. So I think this may give a brief idea of testing an antenna, so that if people are interested in that field, they can take up that work. I believe like that.
Welcome. You're right.
Yeah. So if any participants, if you have any queries, you can ask directly.
I found VK Jain, my colleague in ISRO, sending me some messages on chat box.
Yeah. I'll read it out. Highly informative about antenna measurements and details about anechoic chambers with good pictures, very useful to the students. That is what Jain sir was telling.
Jain and myself are colleagues in ISRO Ahmedabad, and I greet him on this occasion for attending this lecture. I love him, I must say. Thank you, Jain.
Good evening, sir.
Good evening. Good evening, Ravi. And
Good evening, Jain. VK Jain, sir, how are you?
yes, fine. You are educating students and IEEE community. I'm happy.
Yeah,
sharing the information.
last few, I think you was there for the last few.
Yeah. Many of his this thing webinars I used to see.
Yeah. Thank you, sir.
Wherever the technical information there, I love. This Ravi knows this thing. We have been in the same division, microwave components of subsystem division, and worked with under Dr. K.N. Shankara,
Yes,
who is
sir.
the father of the microwave engineering.
Exactly.
Okay.
Nice, sir. Nice.
I think IIT Kharagpur is having a facility, I think.
Yes.
Anechoic chamber, all those things.
Sir, you
SAG
have,
Ahmedabad is also having very good facility. ISRO
this is
Ahmedabad.
the origin for it. And in the education institutions, there is one chamber in Cosset, Cochin University.
Okay. KUSAT. Yeah. Okay.
Cosset. And recently we have installed one Anechoic chamber in Bangalore.
Oh, fine.
One institution. I can give you the details of it. They are also very doing good job. Teachers, they are really enthusiastic.
Okay, fine. I had visited IIT Kharagpur for one workshop, one
Yes,
6-day workshop FDP.
Yeah.
There that was in Antenna, and there they taken us to Anechoic chamber for seeing what is happening inside.
Yes, sir.
Hello.
Yeah, Sabik.
Hello Devaji, you can unmute and you can speak.
Yes, sir. Good evening, sir. This is Nagraj from Matrush Engineering College, Hyderabad.
Oh, nice.
Sir, actually, I'm working on 3D printing of microwave components,
Okay.
and I designed a X-band horn antenna, that is pickup horn,
Okay.
and it got 3D printed.
Yeah.
And I did the metallization using the adhesive copper tape as well as the silver tape.
Correct.
And I tested that at Osmania University Center for Microwave Excellence. And I'm hello, not NERTU, sir. It is Center for Microwave Excellence. It is in the ECE department.
Yeah.
And after comparing the standard horn which we purchased from the Microwave Tech Ghaziabad for the laboratory purpose,
Okay.
and the 3D printed horn after metallization, they are giving the close results.
Yeah, good.
I just know I got to know that there is a Anechoic chamber established in some educational institution in Bangalore.
Yeah.
Will they allow us to test the 3D printed horns in that Anechoic chamber, sir?
I suggest you to do this in Hyderabad itself.
Where, sir?
I can tell you this one company called ACD Communications in where this ECL and off.
Okay, ACD Communication.
Yeah, ACD Communications. You please take down my details.
Okay, sir.
I can help you in accessing that facility.
Okay, sir. Actually, I'm also from IEEE Hyderabad chapter, and earlier I was member in MTT also. We do have MTT student chapter at our college.
Yeah, good.
And earlier, that is in 2015, I attended summer research fellowship program under SK Kaul sir.
Oh, great.
IIT Delhi, and I designed a patch antenna that got tested in Anechoic chamber also. I do have access with the IIT Hyderabad, IIT Delhi.
Yes.
But I'm looking for nearby facilities, and we do have.
Okay. Try doing this. You please.
Okay.
I'm a former immediate past chairman IETE Hyderabad Center.
Okay.
Your colleague Namasiva is my friend.
Namasiva, he is in MVSR, sir. You might be knowing Nukal Srinivasarao, sir. I am working under him.
Okay.
Matru Street, Hyderabad campus.
Very good. Can you please take down my contacts and
okay, sir.
we'll interact and find it out.
Okay, sir. I got to know that the webinar organizer is my colleague's senior in what is called Central University, Pondicherry.
Okay.
Yeah.
Dr. Ashok Kumar has suggested me to participate in this.
Okay.
I'll take down the details from you, sir.
Yeah. You can contact me.
Okay, sir. Thank you. Sir.
You please, your good name, sir?
Nagaraj, D. Nagaraj.
Nagaraj. Okay.
Yes.
We'll get in touch. Thank you.
Sure, sir. Thank you, sir. Thank you very much.
Right, and go ahead.
I believe there is no more questions, I think.
Yeah, you may give a vote of thanks kind of thing. Sabik.
Slima? Okay, the session was wonderful. The speaker, our Ravi Kumar sir, has covered a lot of idea about the anechoic chamber, the size, specification, what is the nature of the chamber, rectangular, square, etc. And overall, I believe that for participants, this was useful. And if all they are interested in working out after their graduation, if students or if their faculties, if they want to do some research, they can take up this area, even though it contains a little bit dry or as was speaking out, a little bit mathematics and other dry fundamentals. So, but I believe the area is very interesting as well as very wide. You can take up several designs of antenna. So, sir has given a wonderful session. So, on behalf of IEEE Malabar Subsection, I thank Professor Ravi Kumar sir for accepting our invitation and giving a 1 hour lecture on topic testing antennas. So I thank once again, and I also thank all the participants who have taken up the time to spend at this late evening for hearing this particular topic. So I thank all of you. So once again, I thank everybody. Thank you.
Jai Hind. Thank you, sir.
Thank you, sir.